equation in two variables. Equation. An equation is a mathematical sentence that has two equal sides separated by an equal sign. 4 plus 6 equals to 10 is an example of an equation. One more example, 12n equals to 24. Where 12 is the coefficient in the equation, a variable is a letter that represents an unknown number. Linear. Means of the first degree with respect to one or more variables. Now for example, check if you look at 12n equals to 24. You have to check for power of n. What is power of n? Power of n is 1. So when you'll get the power of variable to be 1, means of the first degree. Linear equation. A linear equation in which each term has an exponent of 1 and the graphing of the equation results in a straight line. It is made up of two expressions set equal to each other. A linear equation is special because it has one or two variables. No variable in a linear equation is raised to a power greater than 1 or used as the denominator of a fraction. Linear equation in two variables. Definition of linear equations in two variables. An equation which can be put in form ax plus by plus c equals to 0, where a, b and c are real numbers and a and b not equal to 0, is a linear equation in two variables x and y. An example of linear equation in x and y is 2x minus 3y plus 4 equals to 0. A pair of linear equations in two variables can be solved by graphical method, algebraic method. Graphical solution of linear equations. Let us consider the following system of two simultaneous linear equations in two variables. X plus y equals to 6, x minus y equals to 4. Here we assign any value to one of the two variables and then determine the value of the other variable from the given equation. For the equation x plus y equals to 6 and x minus y equals to 4. Now here for the first equation, you'll change position of x. Okay, now here what you can do is you can change position of x or position of y. That depends on the way you're going to solve. Here I've changed position of x. So y will be on the same side. So the equation would be written as y equals to 6 minus x. And in the second equation, it would be x equals to 4 plus y. You've got the two equations. Now you have to make the table for the two equations. Now for the first equation, you'll prepare the table. Here you have changed position of x. So you'll substitute in place of x the values. You can substitute any value. Now here I've substituted as 0, 6 and 2. Now once you substitute x as 0, so the equation would be y equals to 6 minus 0. So that is 6. So value of y equals to 6. So you will get the first set of point as 0, 6. Next, you substitute x as 6. So 6 minus 6, y would be 0. So 6, 0. Next, you'll substitute x as 2. So 6 minus 2, 4. So 2 comma 4. So in this way, we'll complete the table. So our first table is complete. We'll move to the next table. Now here you have changed position of y. So we'll substitute in place of y. So first value will substitute it as 0. So x equals to 4 plus 0. That is 4. So the points would be 4 comma 0. Next is, we substitute y as 1. So 4 plus 1, 5. So the coordinates would be 5 comma 1. Next, you'll substitute y as minus 4. You get that as 4 minus 4, 0. So the coordinates would be 0 comma minus 4. You've got both the tables ready. Now you need to plot these points on the graph paper. Now once you finish plotting the points on the graph paper, you just join those lines to get the graph of the two equations. Now here, first point 0 comma 6. So you'll plot 0 comma 6 first. So check x 0 y 6. So you'll point, first point would lie here. Check 0 comma 6. Second point 6 comma 0. Now here y is 0, so that means it would lie on the x axis here. Check here, this point 6 comma 0. Next 2 comma 4, x2 check and y4. Check x2 y4. The third point will lie here. You join these 3 points, the straight line. Check. At the end, you'll write the name for the line x plus y equals to 6. In the same way, you'll plot the points for the second equation 4 comma 0. Now 4 comma 0, check here, y is 4, so that means this point will lie on the x-axis. So this point will lie here, 4 comma 0. Next set of point 5 comma 1, so x5 y1. Check x5 y1, so your point will lie here. Next point 0 comma minus 4. So check 0 is of x, minus 4 is of y. So it will lie on the negative y axis. So here you will get that point minus 4. Understood? 0 comma minus 4. You join these 3 points with a straight line. Okay. So you'll write the name of this equation x minus y equals to 4. So we've got the graph of the two equations. Now the most important thing here is you have to write the scale. Write the scale on both the axes. 1 centimeter equals to 1 unit. This point where the two lines they meet is the solution. This point where the two lines they are going to meet each other is the solution for this equation. The point of the intersection of the two lines is 5 comma minus 1. So that means the answer for this two equation is 5 comma 1. Types of solution of system of equations. One solution, the lines intersect at any one point. No solution, the lines do not intersect. Infinitely many solutions, the lines coincide. Algebraic method to solve a pair of linear equation in two variables. To solve a pair of linear equation in two variables, algebraically, we have the following methods. Substitution method, elimination method, determinant method, which is also called as the Cramer's rule. Substitution method. Obtain the two equations. Let the equation be a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. Choose either of the two equations, say 1, and find the value of one variable say y in terms of x. Substitute the value of y obtained in the previous step in equation 2 to get an equation in x. Solve the equation obtained in the previous step to get the value of x. Substitute the value of y of x and get the value of y. Solve x plus 2y equals to minus 1 and 2x minus 3y equals to 12. X plus 2y equals to minus 1 is your first equation. 2x minus 3y equals to 12 is your second equation. Now, we'll reshuffle the terms in the first equation. We'll keep x on the same side. So plus 2y when it goes to the other side becomes minus 2y. So your first equation is written as x equals to minus 2y minus 1. This is your third equation. Substitute this value of x in equation 2. We'll get 2 equals to minus 2y minus 1 minus 3y equals to 12. Now 2 multiplied with minus 2y is minus 4y. 2 multiplied with minus 1 is minus 2. So this is written as minus 4y minus 2 minus 3y would come as it is down, equal to sign as it is down, 12 as it is down. So it is minus 4y minus 2 minus 3y equals to 12. You'll get that as minus 7y equals to 14. So y equals to 14 upon minus 7, that is minus 2. Putting value of y in equation 3, we get x equals to minus 2 into minus 2 minus 1. So minus into minus is plus. We'll get that as 4 minus 1. So that is equals to 3. Hence the solution of the equation is 3 comma minus 2. Elimination method. In this method, we eliminate one of the two variables to obtain an equation in one variable which can be easily solved. Putting the value of this variable in any of the given equations, the value of the other variable can be obtained. For example, 3x plus 2y equals to 11, 2x plus 3y equals to 4. 3x plus 2y equals to 11 is your first equation. We're going to multiply this equation with 3. Second equation, 2x plus 3y equals to 4. This you're going to multiply it with 2. Multiplying equation 1 by 3 and equation 2 by 2, we get the third equation. 9x plus 6y equals to 33. Fourth equation, 4x plus 6y equals to 8. Subtracting equation 4 from 3. Now when you're going to subtract, you have to remember the signs in the fourth term are going to change. So plus 4x, understand, plus 4x is going to be minus 4. Plus 6y is going to be minus 6y. And plus 8 is going to be minus 8. So check. Plus 6 minus 6 is going to get cancelled off. 9 minus 4 will be 5. We'll get that as 5x, and 33 minus 8 is 25. So 5x equals to 25. We'll get value of x equals to 5. Now this value we're going to substitute in equation 2. We'll get that as 2 into 5 plus 3y equals to 4. We'll solve this. You get 10 plus 3y equals to 4. So 3y equals to 4 minus 10. So 3y equals to minus 6. So value of y equals to minus 2. Hence x equals to 5 and y equals to minus 2. Determinant method. Cramer's rule. Using determinants, simultaneous equations can be solved easily and in less space. This method is known as determinant method. This method was first given by Swiss mathematician Gabriel Cramer, so it is also known as Cramer's method. To use Cramer's method, the equations are written as a1x plus b1y equals to c1 and a2x plus b2y equals to c2. You represent the determinant in the matrix 2 by 2. So determinant equals to a1, a2, b1, b2. Determinant of x, c1, c2, b1, b2. Determinant of y, a1, a2, c1, c2. Now you'll find value of x with help of these determinants. So x is given as determinant of x upon the determinant, and y is determinant of y upon determinant. Solve 4x plus 3y minus 4 equals to 0 and 6x equals to 8 minus 5y. You need to rearrange the terms. Rearranging the terms. 4x plus 3y equals to 4. 6x plus 5y equals to 8. If you arrange both the equations, then you'll find the value of the determinant. Determinant equals to a1, a2, that means 4, 6, b1, b2, 3, 5. You'll multiply them diagonally, 4 into 5, 3 into 6. So you'll get that as 4 into 5 minus 3 into 6, that is 20 minus 18, that is equals to 2. Now you'll find determinant of x. C1, C2, 4, 8. B1, B2, 3, 5. You'll multiply them diagonally. So you'll get 4 into 5 minus 3 into 8. So that is 20 minus 24, that is minus 4. You've got value of d, you've got value of dx. You'll get value of x. So x equals to dx upon d. That is minus 4 upon 2. That is equals to minus 2. You'll find determinant y. 4, 6, 4, 8. You'll multiply diagonally. 4 into 8 minus 4 into 6. That is 32 minus 24. That is equals to 8. You'll find value of y. Y is dy upon d. That is 8 upon 2. That is equals to 4. Don't forget to press the bell icon, subscribe and share my channel Vigilant.